It's kind of crazy to think about, but that simple network cable you see everywhere, it's often the single point of failure for thousands of dollars worth of technology. It really is the unseen backbone of our entire digital world, and picking the right one is so much more critical than you might think. So today, we're going to pull back the curtain on the surprisingly complex world of network cable.
All right, let me paint you a picture. You go out, you invest in this awesome, top-of-the-line outdoor security camera. It works like a charm for months, and then one big storm rolls through and bam, it's dead. What happened? Well, the answer, and this might surprise you, probably has nothing to do with the camera itself, and everything to do with the little wire plugged into it. Okay, so the first big decision you have to make is what kind of copper cable to use. The best way to think about this is like building a highway system for your data, right? You can build a little two-lane country road, or you can build a massive superhighway. And that choice determines everything, how much traffic can flow and just how fast it can all go.
So let's break down our options. Cat 5e, that's your basic road. I mean, it's old tech. It'll work for a simple camera, but you really wouldn't want to use it for a new install today. Then you've got Cat 6. This is the industry standard right now, a solid multi-lane highway that's perfect for most IP cameras and devices. But if you need serious performance, like for a powerful Wi-Fi access point, you've got to go with Cat 6a. That's your 10-lane superhighway. And here's the bottom line. The cost of ripping out walls to recable later on is absolutely astronomical compared to just getting it right the first time. This choice isn't just about today, it's about future-proofing your entire system.
Okay, so you've picked out your data highway. But what happens when that highway needs to go outside? Well, suddenly you're not just worried about speed anymore. Now you're worried about rain, wind, and oh yeah, lightning. Your cable needs some armor.
That standard cable you see in an office? That's called unshielded twisted pair, or UTP. It's totally fine for indoors, but for the great outdoors, you absolutely need shielded twisted pair, or STP. It's got this metal foil wrap inside, but the real game changer, the key piece of that armor, is a special little something called a drain wire. And this is just a brilliant concept. The drain wire is, for all intents and purposes, a personal bodyguard for your camera. See, as wind whips past an outdoor camera, it builds up static electricity. During a storm, electrical surges can travel right through the ground. That drain wire intercepts all that dangerous energy and safely channels it away to a proper ground, stopping it from frying the delicate electronics inside your camera.
This brings us to a non-negotiable golden rule from the pros. If a device is outside, it must be connected with shielded cable, period. This single choice is what separates a system that survives a storm from one that ends up in the garbage can. It's the answer to that question we asked at the very beginning.
All right, now let's zoom in a bit. We've chosen the right type of cable, we've got the right armor for it, but inside that cable are 8 tiny color-coded wires. And believe it or not, the precise order they're in can literally make or break your entire connection.
So first up, we have what's called the T568 standard. As you can see, it starts with the green pair. This is a perfectly fine standard, and you'll often find it in government jobs and some residential projects. Just keep that color order in your head for a second.
And next we have T568B, which starts with the orange pair. This is the commercial standard you're going to see pretty much everywhere, like 90% of the time. Now, if you look closely, the only difference between A and B is that the green and orange pairs are swapped. That's it.
So, which one is better, A or B? The answer is neither. The only thing that matters, and this is our second golden rule for today, is consistency. Whether you choose A or B, you have to use that exact same color pattern on both ends of a single cable. That's the key.
But what happens if you don't? What if you just match up the colors randomly, as long as they're the same on both sides? It seems like it should work, right? Heck, the little green light might even turn on. But you've just created a nasty, hidden problem that's going to drive you crazy.
It's called a split pair. And here's why it's so bad. The specific twisting of each colored pair of wires is precision engineered to cancel out electrical interference. When you mix them up, you completely destroy that protection. Your cable might limp along at really low speeds, but the moment you try to push high-speed gigabit data through it, the connection will just collapse. And that leads to all sorts of frustrating problems, like glitchy video or lost data packets.
So we've pretty much mastered the ins and outs of copper cabling. But even the best copper cable in the world has a hard physical limit. Think of it this way. Copper is a fantastic sprinter, but it is a terrible marathon runner. And that limit is exactly 100 meters, or 328 feet. After that, the data signal just degrades into noise. It dies. So if you need to connect a camera way out on a light pole in a parking lot or link two separate buildings together, copper just won't cut it. You have to switch from sending electrons down a wire to sending light down a strand of glass. And this is where the magic of fiber optics comes in. For the short-haul connections, say inside the same building up to a few hundred meters, you can use multimode fiber. It uses a pretty simple and cheaper LED light source. But for the long haul, we're talking connecting buildings across a campus or cameras miles away, you need single-mode fiber. It uses a powerful laser to shoot data for kilometers. Now, you can't just plug a fiber cable directly into a network switch. You use this little metal adapter called an SFP transceiver. And the rule here could not be simpler. A multimode fiber needs a multimode SFP. A single-mode fiber needs a single-mode SFP. Trying to mix and match them is like trying to put diesel in a gasoline car. It just won't work. They are built for completely different types of light and are absolutely 100% not interchangeable. Okay, we've done it all. We chose the right cable, we terminated it perfectly, we even ran fiber for those really long distances. And hey, look, the little green light on the switch is blinking. So, we're done, right? Well, not so fast. This might be the single most important thing to remember for anyone installing a professional system. A blinking light only tells you that there is a connection. It tells you nothing about the quality of that connection, and it sure doesn't tell you anything about the speed. Remember that cable with the hidden split pair problem we talked about? Oh yeah, it'll still make the light blink, but it won't actually work right when you need it to. To truly know if the job was done right, you have to test it properly. And there's kind of a hierarchy to it. A basic $50 continuity test just checks, are the wires connected from A to B? A qualification test, that's a bigger step up, it confirms if the cable can actually handle the high speed you need. But for any serious project, you need a full certification. This is a deep analysis that proves the cable meets every single performance standard, and it's almost always what's required to get that 20-year manufacturer's warranty.
So when you think about it, from the type of copper and its outdoor armor, all the way down to the precise order of 8 tiny wires and that final proof of a certification test, that network cable is so much more than just a wire. It's the absolute lifeline of the entire system. And it really makes you wonder, what other critical, invisible details like this are hiding in plain sight all around us?